Imagine a sound that isn't just loud, it's a force that rattles your bones, a shockwave that seems to vibrate the very air around you. It's not just heard, it's felt, deep in your chest, echoing through your body and leaving your heart pounding. This is the scream of a Formula One car at full throttle, a mechanical symphony of precision and violence, where every component is pushed to its absolute limit. The roar is a blend of art and engineering, a sound that signals the start of something extraordinary. These aren't just cars, they're land-bound rockets, carbon fiber masterpieces built to defy physics. Every inch is sculpted for speed, every part designed to slice through the air with minimal resistance, transforming raw power into breathtaking motion. When one flashes by, you're witnessing a blur of color, technology, and the edge of human achievement. It's a fleeting moment where innovation and adrenaline meet, leaving spectators in awe and hungry for more. The driver is just the tip of the iceberg. Behind them is an army of engineers and scientists, each obsessed with perfection. Every race is a culmination of thousands of hours spent in wind tunnels, on computers, and in the garage, chasing fractions of a second. Every bolt, every line of code, every aerodynamic tweak is the result of relentless work and endless experimentation. It's a world where the smallest detail can mean the difference between victory and defeat. Formula One is a global phenomenon, but beneath the glitz, it's a weekly battle of innovation and wits. Teams travel the world, adapting to new tracks, climates, and challenges, always searching for the next breakthrough. Each car is a rolling laboratory, streaming data in real time, every lap a new experiment. Engineers analyze thousands of data points, making split-second decisions that can change the course of a race. Teams race not just each other, but the clock, their own limits, and the boundaries of science itself. Every race is a test of human ingenuity, courage, and the relentless pursuit of speed. The engine's scream is more than noise. It's the sound of progress at 200 miles per hour, a living testament to what's possible when passion and technology collide. It's a testament to the human drive to go faster, build better, and understand more. Every innovation on the track eventually finds its way into the cars we drive every day, shaping the future of mobility. This is Formula One, where science, speed, and spectacle collide in a breathtaking display of what humans can achieve when they dare to dream big. And it all starts with that unforgettable scream, a sound that marks the beginning of every race, and the endless pursuit of the impossible. Formula One isn't just about the driver's skill, it's an engineering war fought in the garage. 10 teams, each a powerhouse of design and technology, battle to build the fastest, most reliable machine within strict rules. The drivers are the jockeys, but the teams are the ones breeding the thoroughbreds. Every race weekend is a deadline for new parts, new software, and new strategies. Margins are razor thin. A tiny tweak can mean the difference between victory and defeat. Supercomputers run endless simulations. Wind tunnels test thousands of designs before a single part is made. What you see on track is the tip of a year-long iceberg of innovation. Each car is a unique answer to the same question: how do you go faster? The driver extracts the final tenth, but the foundation is built by hundreds of unseen hands. Formula One is the ultimate fusion of human talent and technological genius. A Formula One car generates so much downforce, it could theoretically drive upside down at speed. This isn't just a wild claim, it's a testament to the incredible grip these machines create, using the very air around them as an ally. Unlike airplane wings, which are designed to lift, F1 wings are engineered to do the opposite. They push the car down, gluing it to the track with immense force, allowing drivers to take corners at astonishing speeds. Downforce is the invisible hand that lets these cars corner at G-forces no road car could handle. It's what separates a race car from anything you'll see on the street, letting drivers defy the limits of grip and physics. The car's floor and diffuser create a low-pressure zone underneath, sucking it to the tarmac. This ground effect is a marvel of engineering, turning the entire underside of the car into a giant wing. The faster it goes, the more it sticks. As speed increases, so does the force pressing the car down, letting drivers push harder with every lap. But there's a catch. More downforce means more drag, which slows the car on straights. It's a delicate trade-off between cornering grip and top speed. That's why engineers are always searching for the perfect balance, tweaking wings and bodywork for each track. Every circuit demands a unique setup, and even the smallest adjustment can make a huge difference. Every surface, from winglets to side pods, is sculpted for aerodynamic purpose. Even the tiniest flick or curve is designed to manage airflow, reduce drag, and maximize grip. The result is a machine that dances with the air, mastering physics to achieve the impossible. It's a constant battle between speed, grip, and the laws of nature. When you see an F1 car, imagine an upside-down airplane, built to stick, not soar. It's a flying machine, but its mission is to stay glued to the ground. It's a beautiful, invisible ballet of fluid dynamics where every movement is choreographed by science and speed. That's the art of downforce, a symphony of engineering, physics, and pure racing passion. In most sports, the equipment barely changes. In Formula One, the car is a living project, constantly evolving. The car that starts the season is just a baseline. By the final race, it's been transformed. Between races, factories run non-stop, analyzing data, designing, and building new parts. Upgrades are flown across the world and bolted on just in time for practice. Every team is locked in a relentless arms race. Standing still means falling behind. Innovations are kept secret, but copied in weeks. The car's shape, wings, and bodywork visibly evolve over the season. Each change is thousands of hours of research and manufacturing. Teams don't build one car a year. They build a dozen versions, always chasing the next breakthrough. It's a frantic race against time, rivals, and the limits of possibility. That's the heartbeat of Formula One innovation. Formula One is one of the most expensive sports on Earth. Top teams spend over $400 million a year just to compete at the highest level. That staggering budget covers everything from the latest technology to the salaries of hundreds of specialized staff. That money fuels relentless research and development, pays for state-of-the-art factories, and moves an army of people and equipment around the globe for every race weekend. Each season, teams ship tons of gear by air and land, ensuring nothing is left to chance. For most teams, F1 isn't profitable. The real value is in prestige, global exposure, and marketing power. The dream of winning brings sponsors and fans, but the financial risks are enormous. For car makers like Mercedes and Ferrari, success on the track is priceless. Winning on Sunday boosts their brand image and helps sell cars on Monday, turning racing glory into real-world sales. For brands like Red Bull, F1 is the ultimate global advertisement. Their cars race in front of millions, and every victory cements their image as daring and innovative. Sponsors pay millions for a spot on the car, chasing the sport's massive TV audience and the prestige that comes with being part of the F1 spectacle. But the days of unlimited spending are over. A new budget cap now forces teams to spend smarter, not just bigger, leveling the playing field and making efficiency essential. Every dollar is a strategic decision: where to invest, what to develop, and what to risk. Teams must carefully balance performance upgrades with financial discipline. The cap has turned F1 into a high-stakes game of financial chess, where clever planning and resourcefulness can outmaneuver raw spending power. Teams must innovate within strict limits, making every choice count and squeezing maximum performance from every dollar spent. The result? Even more intense competition, both on and off the track, as teams fight for every advantage in a world where margins are razor-thin. In F1, money fuels the race, but brains, strategy, and innovation are what truly win it. Formula One's technology isn't just for the racetrack, it shapes the cars we drive every day. F1 engines are marvels of efficiency, squeezing over 1,000 horsepower from tiny hybrid units. Their breakthroughs in thermal efficiency and hybrid systems have pushed road car technology forward. Energy recovery systems pioneered in F1 now power hybrids and electrics on the street. Paddle shift gearboxes, carbon fiber, advanced traction control, these all started in F1. Even tire pressure sensors and lightweight materials trace their roots to the sport. If a technology survives a Grand Prix, it's proven for the real world. F1 is the ultimate proving ground, accelerating innovation for everyone. The next time you drive, remember, your car owes a debt to the relentless pursuit of speed. Formula One's legacy is in your garage. That's the trickle-down of racing genius. Formula One is more than a sport. It's a public R&D lab for the auto industry. The FIA's rules push teams to solve real-world problems, like making hybrids powerful and efficient. 10 teams, hundreds of millions in funding, all racing to out-innovate each other. Ideas are tested, proven, or discarded at breakneck speed. The best breakthroughs set new industry standards. While designs are secret, the principles eventually spread, fueling progress everywhere. F1 makes new tech cool, turning efficiency into performance. It's a safe space for high-risk, high-reward experiments. If it works in F1, it can work for everyone. That's how Formula One drives the future. The world is going electric, and Formula One faces its biggest challenge yet. The next generation of F1 engines, coming in 2026, will draw half their power from electric motors and run on 100% sustainable fuels. This lets F1 keep its signature roar while pioneering carbon-neutral technology. Sustainable fuels could revolutionize transport far beyond racing. F1 is forcing the world's best engineers to solve problems that matter to everyone. The challenge: keep the spectacle and passion alive while leading the green revolution. Formula One has always adapted. This is just the next chapter. By embracing hybrids and sustainable fuels, F1 aims to lead automotive innovation into a new era. The finish line is moving, and F1 is racing toward it. The future of speed is being written now. At its core, Formula One is about pushing boundaries, never settling for fast enough. Every car is an engineering marvel, but teams are already working to make today's machines obsolete. F1 is a microcosm of scientific progress: test, fail, learn, improve, repeat. Every component is the result of relentless refinement. As the world shifts to new priorities, F1's role as a laboratory for bold ideas is more vital than ever. It inspires, excites, and turns engineers into heroes. Science and technology become tools for the extraordinary. When you hear that scream, remember, you're witnessing the cutting edge of possibility. Formula One is more than a race. It's a rolling testament to human ambition. The finish line is always moving, and the real victory is in the chase. That's the spirit of Formula One.